Wise. Okay, not cooperating. All right, so it is, yeah, it's Berkeley time. Cool. All right, everyone, so welcome. Welcome back to the fall semester. Welcome to CS169. I'm Michael. I am the newest lecturer in the CS department. I graduated from Berkeley 3 years ago studying CS education, and I've been working at Gradescope for the past few years, which I assume all of you have used and have various relationships with. It is, the tool that you get your scores with is always a fun thing to use. So this is CS169. It is software engineering. We will be talking a lot about how we build software, the process behind it. There will be a lot of coding. The code is also not the point of this class. So we'll talk about that today. And as soon as my computer cooperates, we will actually get going. There we go. So does anybody know who this is? Oh, why? That is not very effective. Why? Okay, you know what? One second. This iClicker app is not exactly cooperating. Come on. There we go. There's that. And, oh, well, okay. Now that, give me 1 second. Okay, there we go. Does anybody know who this is? So this is Margaret Hamilton. And one of the things that we'll do in this course is have a little bit of computer history sewn in throughout every so often. And the reason for this is it illustrates the sort of the history of software engineering as a discipline, as a practice, but also there's a lot of genuinely interesting things. So Margaret Hamilton is one of the people who was on the original Apollo software engineering team, and so we're going to play a quick clip, assuming this, no, it's going to make me, let's actually do this. No, you are not going to cooperate.
Altitude 5,200 feet.
Oh, well.
Manual attitude control is good.
Okay. 1 sec. Why are computers so annoying? Okay. Come on. No.
Roger, copy. Altitude 4,200. Houston, you're a go for landing, over. Roger, understand. Go for landing. 3,000 feet. Copy. Alarm. 1201. 1201. Roger, 1201 alarm. Where go? Same type. Where go?
So it's a little hard to hear, but in this clip, there's the word alarm that's said. And this is one of the interesting things about talking about computing and computing history. So what's happening here is on the Apollo space, on the mission, they have antennas which are processing various signals. As they are landing, the computer, which is a 1969 processor that is being sent to space, so limited by computing resources in a million different ways compared to what we'd think of today, it couldn't process all the data that it needed to process at the same time. So one of the things that Margaret Hamilton invented is this idea of dynamic resource scheduling. And what had happened was one of the astronauts had left an antenna signal open that it was trying to process, and instead the computer was dropping that task to focus on processing the landing maneuvering so that you could actually land on the moon. And so what the computer is saying is alarm, and that it was dropping some tasks. And so this is just one of those bits of things that as we look at software engineering as a discipline, there's not just the code that we write, but the tools and ideas that we have to end up processing this code. So there is also, why are there? Okay. So there's also a GitHub repository of all the code that was used for the Apollo missions. It is in the public domain. It was a taxpayer-funded project, of course. So that is something that if you're interested in taking a look at some old code, can be a very interesting thing. So this is Margaret Hamilton with the team of MIT software engineers. It is a very 1960s photo, but they're the ones who wrote much of the software that runs or that ran on the Apollo missions. So does anyone have some ideas of what they think we're going to talk about when we talk about software engineering versus just programming in general? And if you are in the back, it's a bit dark and my eyesight is not the best, so just like wave your hand and I will, or shout out if I miss it. But otherwise, yeah, does anyone have some ideas as to what software engineering would be? Like, what are we talking about when we say that there's a difference between just software engineering and programming or writing code? What might we care about?
Meeting the requirements.
Requirements, yeah, absolutely. So it's not just something that we can just build for ourselves. There might be a customer, there might be a specification to follow. That's certainly going to be a part of it. What else might we have as a distinction with software engineering?
You can say like programming is a part of software engineering, but then
Yep.
software engineering is like the whole process, like documentation and meeting and stuff.
Yeah, absolutely. Yeah, so definitely going to be programming. It would not, be a computer science course if there wasn't a significant amount of programming in there. What else? Is there any other big things? Yeah.
Extensive documentation.
Yeah, you could say extensive. We'll talk about how extensive it needs to be and whether or not we always need it to be that extensive. There's one other aspect. What is a core piece that you've hopefully heard about this course? Yeah.
Working as part of a team.
Yes, absolutely. So working as part of a team, and really, I don't care that you can't join the Wi-Fi network computer. Yeah, so working as part of a team is absolutely one of the biggest distinctions here. And so working as part of a team includes multiple things. This is you and your 5 other teammates for this course. This is when you go off to take an internship, a job after graduating. This is your immediate team. This is an organization. This might not be people that you know. If you're working on an open source project on GitHub, you are potentially collaborating with any number of people around the world who might even speak a different language than you. All sorts of things you might have as a team. So multi-person is a key piece. So this is a photo of David Parnas, who is influential in software engineering. There are going to be names and photos of people. They give illustrations as to where some of these ideas come from. The point of this course is not to memorize who these people are or their names. But they are there as a background and to point out that we are not just inventing all this material. So this is a quote from Fred Brooks, who is a Turing Award winner. And this is a really interesting piece too, combining separately written programs and making them suitable for use by people who had not written them. And I think the part there that's interesting is the idea that software that gets used in production is not just a single piece of code, right? In CS169A, you're writing assignments that largely live on their own. Towards the end of the course, you get into some more complex projects, but in general, it's one sort of encapsulated bit. Software, evolves over time. For people who had not written them is also a critical component, and one of the things that we'll focus on, all the bits around your code that help you with this aspect. So, and it's worth noting that people who had not written them will repeat again and again, will include you in 3 months. In a course project and in internships, you don't often get the chance to go back and look at your own code months later or even years later. But when that happens, you don't always have the same context. So having the tools, the processes, the infrastructure around your code to help with that will make things easier when you do have to modify, maintain, and adapt things. So those are a bit about sort of a high level what we think software engineering will be in this course. So when this course was developed about 6 or 7 years ago, professors David Patterson and Armando Fox went and surveyed a bunch of industry partners who work with the EECS department, and they said, what are that is actually the next slide. Well, they went and surveyed a bunch of things about what we need, and then at the same time, this is now, I believe, only 3 years ago, there was another survey that was done by Microsoft and the University of Washington, which is what are some of the aspects of an individual software engineer that are looking for. So these are individual aspects. So improving, self-driven, what makes you work well on a team. We have the team aspects of what are you doing not just within yourself, but how do you operate on a larger team. So giving feedback, the important one here, and this is true of education, is creating a safe haven. So how do you, respond to questions when someone is uncertain about a process? You say, I am trying to, let's say, load 1 million users into a database efficiently, and you're wondering how you can do that. Making sure that it is a safe space for those questions, which, at any time within the projects in this course, you will run into something that you absolutely do not know how to do. There will probably be things that you will ask your GSIs or myself that we do not have an exact written script for how to do those either. And it is perfectly okay to throw out wacky ideas, just say, I think this might work, I have no idea. So within those course, within a software engineering team, that is an important aspect. And so I hope that as you're working together, you can cultivate this within your smaller project groups, but also the course as a whole. We'll talk about that. So, other sort of important aspects, on the technical side, of being a software engineer. So, the intrapersonal stuff and the interpersonal stuff is all super important. But of course, if you are building code, having the proper technical background is important. And at this point in Berkeley, you've hopefully had 2 intensive years of lower division courses, maybe an upper division course or 2 as well. And so, you are already well on your way of having the technical chops there. But that will be another big piece. And so, the final bit is just, in the pieces of decision making, what, are you going through the steps? Are you thinking critically? Are you helping, document and define those processes? And, there's a lot more here, but these are sort of the highlights of each piece of the process. So this is what, one of the surveys as to what makes a great software engineer. And you can sort of distill this course down into one slide, which, disciplined, customer-focused, agile. So, when we talk about this, we'll spend a lot of time in this lecture and in the next week sort of what the word agile means. I'll note that it is a lowercase a here in terms of not trying to be too dogmatic. And then software engineering, which is the discipline, and software as a service. So what we'll be working on, what you'll be working on, are projects that are web applications backed by a database that solve some customers' needs, that are deployed to the cloud. So if you've had an internship, you've probably worked on something similar. It is sort of the backbone of what you think of today when you think of a modern technical startup, or even not a startup anymore. But most of the projects and programs that you use in your daily lives are probably software as a service now, or have a component of it as well. So expectation setting for this course. We assume you know how to code pretty well. You have made it this far in your Berkeley career. That is not too much of a problem. Second assumption, you have a GitHub or GitHub student account. You don't need the student-specific features of GitHub, but if you sign up for them, there is a lot of great freebies. If you don't have a GitHub account already, you can just go ahead and create one. That is where you'll be working on your projects. We'll talk a bit about that in a second. But that is GitHub will be a great piece of this course, both for how we manage projects and something that you will probably use in the future as well. And if not GitHub, you will very likely be using a similar piece of software wherever you go to work. So the goal here is to prepare you for the future of what you're going to be doing in an industry setting, in a lot of research settings, anything like that where you're building software that it's more than just a weekend hack project. So does anyone want to guess the answer to this question? Will this course teach me JavaScript, React, Ruby on Rails, Django, your framework of the day? Does anyone have a guess of what the answer to this question is? No. Yeah. And the reason for this is frameworks come and go, right? They change rapidly. They also, Rails itself, which we will be using, has more than a decade-long history now. It is, I believe, about 15 years at this point. So they don't just totally come and go, but the goal here is not to learn or not to teach you, just the mechanics of Ruby on Rails. Will you learn them? You absolutely have the opportunity to learn them. If you get invested in your project, that will be the most, extensive way to really get your hands dirty with a framework. We are going to focus in this course on the server-side component, but when I took CS169, Angular was the hot JavaScript framework at the time, and a number of project groups dove in and built really nice experiences in Angular because they wanted to learn it. It delivered a feature of their project where it was appropriate to do so. But while we will use Rails as a vehicle for this course, the intention is not necessarily to help you become a Rails expert. And so in terms of what is necessary for this course, you really need both components. Lecture is necessary but not sufficient. Reading the textbook is necessary but not sufficient as well. The textbook is, we'll talk about that a little bit more specifically in the logistics section, but it is designed to go deeper on specific topics than will be presented in lecture. We will have some new draft sections for you as well. And so, do make sure you're reading the textbook. It is not a heavy textbook. It is meant to be, concise and to the point, but it does have a lot of good examples. It is, I'll say this as when I was a student, one of the few textbooks that I actually read. And so, take that for what you will. But I actually did enjoy reading this textbook as a student, and it's been improved since then. So, we'll make sure that everyone, hopefully has a good experience there. So, this is a slide that I meant to that I was jumping ahead to earlier. Is what is missing from students' technical skills? So, some of the things that when you talk to employers, you ask them, what do students come into an internship come out of school, what do they not have experience with? So one of them is legacy code. At this point in your school career, you have pretty much worked on projects which have either been scaffolded, a homework assignment where you're filling in a piece of code, or you're starting something from new, right? In CS169 you pretty much get a blank slate and write everything from scratch. And it is an invaluable way to learn. Every project starts off, as having, a blank slate in some form or another. But one of the skills that you really need to have is working with legacy code. So a lot of your projects in this course will be starting from a project that other CS169 students have taken that is being used by a customer, and you'll get to continue, having that application live on. You'll be working with code that is written by maybe 6, 18, 30 other students over the past few years who you basically get to pretend do not exist. They all very much exist. They are around, graduated, working, but you can't go ahead and say, hey, how does this piece of code work? What's in the project repo is sort of the piece of that. So legacy code is one aspect. Some of you will work on new projects, but most of you will be working on a legacy project. We will have homework assignments that are designed to sort of give you that experience regardless. Working with non-technical customers is also a huge component. So one of the great things about CS169 in the project component is the groups that you work with are nonprofits, campus organizations, NGOs that need some software built, and they don't always have the technical experience to describe. They're not going to tell you this is the schema that I want for my user model. They'll tell you a set of requirements, and you get to go work with it. A few of you will be working with technical customers for your projects. And so I will probably be the customer for 1 or 2 projects. Your GSIs might be a customer for 1 or 2 projects as well, depending on which ones you get. So you will definitely have some projects where the customer is technical, but the goal there will be, we're still not going to tell you how to spec out the user model. And working with a technical customer sort of has its own different set of challenges, but we're going to try and act in the most sort of non-technical way as possible. Professor Fox will be a customer for a couple projects as well. And when he's a customer, he works in the same way. And of course, the big one, testing. Definitely a thing that everyone says, introductory software engineers don't have as much experience with. So this course will go through the aspects of testing, different types of tests, how we can make it easier to test our apps. And so we'll be doing this as homework assignments throughout your project. You'll have intimate experience with other people's tests when you start adapting their legacy code, and you get to decide how helpful or not those test cases were. But by and large, we hope that they would be very helpful. So the project theme of this course is, I think an extension of being a public university is do well by doing good. So you're going to learn a lot in this course, and the projects that you take on will be helpful to those in the outside world. What these teams need, what these other groups need, are often automating processes, keeping track of data, things that software is particularly good for doing. And by building these applications, you can really help a group accomplish their mission in a way that they're definitely not going to have millions of dollars to go out and hire a consulting firm to build an application. And so that is the goal of this course. I'm going to pause right here before we get to this. Questions so far on the course, how people are doing, anything like that. We will have a logistics section in a bit, so save the logistical questions, but any questions so far on CS169 or anything that I've said? Trying to look in the back. No, cool. So this is an overview in 2 slides of what your projects will look like. So there's a repository, code. It lives on a server. It usually also lives in GitHub, and it's deployed most commonly to Heroku. If you haven't used Heroku, it's a very nice and easy to use platform for deploying your software. And in this version, this is sort of the canonical live example of an application. Most of these are in use today. You'll be working on taking over some of these projects, but that application is going to live there, is going to be in use during the semester. And what you have is your team's copy. So it's called a fork on GitHub, but terminology doesn't matter. And there will be sort of one canonical repository for your team this semester. You will each work on your own local copies. And we're going to use this model called branch per feature, where your team members will work, in a team of 6. You'll have, 2 or 3 different features going on at any one given time. So you'll learn how to work with Git. You don't need to become a Git expert. You don't even need that much advanced knowledge, but you will get experience with it if you haven't already. And the idea here is that you're going to be having access to see how a code base evolves when multiple people are working on it at the same time, taking it in a similar but also potentially different directions of adapting various parts at once. You'll be doing this with multiple teammates. And then you will, as the semester progresses, make pull requests back. So as you do each iteration of the project, you'll say, I'm finished. You'll have an opportunity to discuss that as a team with your GSI, and that will go back into your main repository. And along the way, when we do this, we're going to be working with some industry standard tools. So Travis CI is a framework, is a tool which lets you use a framework called continuous integration that helps you essentially test your code as many times as possible. Every time you push to GitHub, you'll be able to run a series of tests, and you'll get those results back. So the idea here is, we're going to use tools to make your lives of building better software easier. Code Climate is a tool which has a series of things like linters and static analyzers. No, Siri, I don't really need your help. Code Climate has linters, static analysis tools. It gives you a score. So this score will be loosely part of your project grade. It's not that you have to get their scores, I believe, out of 4.0 because it used to actually be a letter grade. But the idea is that, are you taking steps to improve the quality of the code base? And the great thing here is that it is a robot doing tasks that robots are well suited to. Are you following the conventions of the existing code base? It's not going to be strictly about your project. We're not saying you have to have 100% score all the time. But it's about maintaining a healthy code base. And Coveralls is a similar application. It tries to measure test coverage. All these tools are meant to be used as tools. They all have their quirks and metrics that make no sense at times, but the general idea of ensuring that as you write code, you have parity that it's covered in tests will be an important part, and these tools will help you reflect that. So you'll see badges like this on many open source projects. You will have the opportunity to see those reflected in your own READMEs in your projects that you work on. And then, assuming everything is good, you'll be deploying a second copy of your application to Heroku throughout the semester. And so that will be an opportunity to actually experience the whole life cycle of software development. And then once that code is deployed, your customers will give you feedback on how it's been going so far. So, they will be interacting with a version of their application. Hopefully, most of these customers that are returning customers will also have experience with the previous semester's version of the app as well, though not all of them will. Sometimes it'll be a new person from that group, but they'll be able to tell you, what's changed, how that feels. Sometimes they will find bugs for you, but they are not. They are the customer, so you're building things for them, but they are also not necessarily your QA team. And at the end of the semester, and maybe sooner if everything is good, your work will be merged back into that live application. So the intention here is for every team to have software that actually gets put into the real world, is in use, and many projects from this course have lived on for years. Some live on for a semester, but the goal here is to have something that is long-lasting. So those are the tools. You will be using a lot of tools. Don't worry too much about the specifics. You don't need to go and sign up for all of them right away. Take them one step at a time as you get set up with your project. As you're working on things, learn a tool at a time. We'll go through each of them in the beginning. So, this is sort of the human side of what this process looks like. So you're going to start talking to a customer. Then you're going to probably have some form of a mock-up. So this could be a sketch. This could be a PowerPoint slide. We'll talk about tools for doing that. And then what you're going to do is you're going to take that mock-up and you're going to write a user story. So when a user logs in, this should happen. When a user creates a new entry, whatever that may be, maybe it's something that tracks some sort of customer interactions, this will happen. And you'll work with your customer on those user stories. And then we're going to use this tool called Cucumber, which helps you write these user stories as useful software tests in a very English-like way. So the idea is that when you're looking at a test file, you will have a very clear description of what you expect that software to do. So you'll be able to take those user stories, turn them into tests. Then, so the next kind of piece is with tests, we're going to try and get you into a test-first mindset. It is not always natural to write your tests first. So, it is something that I think will be a little bit foreign at first. If you've done it on an internship, that'll be great. But I expect, most people have not had test-first software development as a discipline. Give it some time. You're going to write tests. They're going to fail, and you're going to see a bunch of red dots. And that's never the best feeling. But what will happen is as you build your feature, those things will pass. And so it is a great feeling to see something go from red to green as well. Along the way, you and your customer will have access to Pivotal Tracker to track the stories that you're building. And then at the end of it, you'll deploy. So deploying, this will be multiple times throughout the project. Whenever you have something ready, so we're going to work in iterations. But you can, get your code out there as a team. You don't have to always, wait for us. But we're going to encourage you to keep testing and deploying code as long as you go through this process. So the faster, your team works, you'll have more opportunities to actually, push your code out there and see it working on a live server. And at the end of each iteration, we kind of start all over again. So you will hopefully be doing 4 of these iterations in the course. That'll be 4 2-week iterations. But that will kind of depend on the actual flow and speed of the course. But along the way, what you're going to get is some experience here. So legacy code. After you've built a feature, you might wait a month to adapt it again. You might be adapting someone else's code from the past semester, and then you'll learn some design patterns. So, we'll talk more specifically about those, but the idea is that we're going to help you write code in a structured way here. So that is software engineering in 2 slides. There is a lot there. Don't worry too much about the specifics. But the goal will be, as we go in, to get into a natural process. So there are a few of these slides throughout the course, which is how to have a poor time in CS169, how to do everything wrong. So skipping lecture, we don't need to do it, right? It's all webcast. Just watch it online. Don't do the homeworks because they're just homework assignments. They're contrived, they're small, nothing to learn there. Work alone. This is, you're going to be competing against your peers because everything is curved, right? So don't help your peers. Yeah, I cannot talk today. You don't need to learn anything new because you've already had an internship, right? So don't worry about that one. Ignore process. The steps don't matter. Everything. I think especially go for points, right? Like the learning here doesn't matter. We have everything will be graded. Just try the exams. Don't worry about anything else. And then obviously cheat, because if you cheat, we probably won't catch you. Don't do any of these things. The thing that I will highlight especially is on the points side with this course, your project grade will be based not just on, are your tests passing, is code climate looking pretty healthy, but it'll be about all the bits and pieces that go into that work. So are you working with the team? Are you, trying to keep up on GitHub? Are you, documenting things with user stories? Are you writing tests? I'll tell you that the grading of this course is a pain. It will be a little bit messy at times, but the idea here really is that throughout this course, the thing that will matter most for your grade is participating in all the different areas possible. So, I don't have the clicker base station working today, so there's not going to be any today, but we'll be doing clicker questions and we'll talk a bit about that. But in the project grading, it's very holistic. There will be surveys of how your team members are working, which will impact their grade. You cannot just say, hey, my teammate sucks and we're not going to fail them because you somehow got into a fight the last week of the semester. We're going to take everything into account, including the code that you write, the surveys from your teammates, your practice on the homework. Of course, exams will be a component of this course, but the goal here is to make sure that you really have a well-rounded experience, because when you are in an internship, when you are building software professionally, every piece counts, and a project can be derailed for any one thing going wrong. So just remember that the goal here is to sort of balance out the lecture with the with the code, with the project work, with everything like that. So for anyone who's also using webcast, there are a bunch of slides that say end. These are meant if you're reviewing the webcast as a place to pause and reflect. They also sort of chunk up topically the lecture into various sections. So any new questions on this stuff so far? If you're in the back, just wave your hand because it's ARC. Yeah, question in the front or no? Oh yeah, go ahead.
So is Rails the only framework that is allowed?
We try very hard to push people towards using Rails if you're doing a new project, because it's the place that we can offer you help. If you have a project in mind that is an existing client, and there is some reason that it can't be Rails, we can talk about that. In the past 5 or 6 years, I think there are maybe 2 examples of Rails not being the framework. But those examples have used something like Django, where it's the exact same setup. You work with a customer, you have tests that are written as user stories, you have continuous integration, you have code climate, you have GitHub. So there may be a limited circumstance in which Rails is not the framework, but it will very likely be the framework for your projects. It will be the framework for all your homework assignments, and it will be the examples that we use on exams. So exams are not going to test your knowledge of Rails. We're not going to say, pull up a document and figure out, what the heck is going on, what is Rails doing here. But, we will be using that syntax so that everyone has a common base. So if there's a need, we can talk about it. But I expect most projects will use Rails. On the front end side, we try and not have people build super front end heavy apps as a requirement. Teams are more than welcome to, as long as they are meeting their customers' needs. And so, the focus will be geared towards the back end, but it's really about meeting your customers' needs. So if you want to learn React and it solves a particular problem, you're more than welcome to use that. But the goal is make sure you solve your customers' needs first. Cool. Any other questions before we go on? Is there one in the back or middle? No, okay. Or if there was, just shout it out, because the lights are kind of in my eyes. So we have 3 TAs for this course, Jeremy, Shrujay, and Nick. They all have experience with building software. Srijay and Nick recently took CS169, so they can give you all the tips and tricks specifically to this course. Jeremy is a PhD student at Berkeley studying CS education, so his experience is also super valuable here in terms of how are we giving you the tools that we need. But 3 sections, you will be meeting with your project team in your section, and your GSIs will be your guide in terms of working on your project, working with your customers, managing that interaction. So it will be imperative that everyone goes to section and that you go to section as a team. So this is our book, Software Engineering as a Service. It is available online. You can get the ebook version, you can get a physical version. It is about $10. And if for whatever reason this, you have a financial hardship, let me know and we can get you a copy. If it's an issue, don't worry about it. Just let me know. You can email or private note on Piazza. Everything you need will be linked through B courses. So everyone should be enrolled automatically. We are making sure that all the bits are updated, but there'll be a schedule there. The syllabus has all the lectures. Will have links to readings and things like that. Okay, waitlist enrollment, the not so fun stuff of having the largest major on campus. We will try and get through as much of the waitlist as possible. This is an early drop deadline course. So until next Friday, you have to decide if you want to be in this course. If you're in this course past next Friday, you have to appeal to the dean to drop the course. I don't have personal experience with this, but past stories have told me that it is not very easy to drop the course after an early drop deadline course. So make sure that if you are wavering and whether or not you want to, take CS169, pay attention to the deadline next Friday to drop the course. If you are a junior and you're unsure and you think it's not going to work out, you will hopefully have, multiple times to take this course. But just be mindful of that. After a few people drop, we'll try to process the wait list. Right now, enrollment is full at 90. We may be able to open it up to close to 100. As you can see, this room is full. So that is a limiting capacity there, as well as the fact that we only have 3 GSIs. So, we will do our best to make sure that we let everyone in who wants to be in the course. But if you think you will not be able to take the course, if you're unsure about the project, please be mindful of the early drop deadline and give your peers a chance to enroll if you won't be taking it as well. If you have DSP accommodation letters, I've gotten a few, but please still post a private note or email on Piazza about it. Regardless of what your letter says, if you have a DSP letter, I want to hear from you about what you need to be successful. The letters don't always describe in your own words what you need to be successful. So please let us know as soon as possible so that we can provide you with the things that you need. And if there's something that's not in your letter that's reasonable, just let me know. So this is the book. You can get it on Amazon. You can get it, sassbook.info has it. There will be a couple chapters of the book that we are linking from the syllabus that are draft chapters, including some stuff late in the semester that is actively being written. So you will need a copy of the book, and then we'll just highlight when we have additional links for newer material. But there's been some really exciting developments since the first edition in that, software engineering is not a static discipline. Things evolve and adapt. So there'll be some new focus on API first development, how to better separate your front end from your back end, what concerns look like there. And iClickers. So we will be using iClickers. They are annoying, they are finicky, but they work better than lots of other things. I will try and enable the online sort of reef pulling option if you want to use your smartphone. But usually the easiest thing to do is to rent a clicker If you have someone who is not taking CS169 and does not have a lecture at this time of the day, and you are comfortable, borrowing a clicker from a friend, I've been told that the registration thing works as long as you're in 2 different courses. You can, share a clicker. So, you don't need to buy your own. There is an ASUC program to rent them for, I believe, $5, and we'll make sure that link gets on Piazza. All the Berkeley stuff links to a Facebook page that hasn't been updated since 2018. So I don't know exactly where the most current information is, but there's some emails on the Berkeley page about iClickers. And we will have a webcast. So if you're absent for a day, if you can't make it to lecture, the webcast will be available. And then section is required. So for Tuesday's sections, please kind of, just go to a section. If you have a group of people that you expect to be, a team, please try and make it to that section together. That will be the hard requirement on section attendance, is that all of your project members need to be in the same section together. And then other than that, just go to section. After Tuesday sections, we will try and, respect your preferences. There'll be a sign-up sheet for getting people, in the sections that they need. But that will be, for next week, just go to a section, and then after that, we'll have, you'll have your time for the rest of the semester. So slides will be on B courses after lecture. Just, make sure they're there if you need to review them. We're going to try a new thing for CS169 this semester. So please bear with us if it is a little bit bumpy at first, but we're going to be doing all the auto grading through Gradescope this semester. So past semesters of CS169 have used edX as a platform, and edX is its own beast. We are trying to limit the number of places that you need to log into and submit things to. So you will already be using Gradescope for exams. You should already have all used Gradescope. If you're a Berkeley student and haven't used Gradescope, I highly encourage you to start, because you've been missing out on reviewing your exams. And so, just make sure you're paying attention to that. And then, next week, homework 0. There is, software is always a challenging piece. So late next week, we'll try and have some office hours dedicated to helping everyone get, installed and set up with the tools that you'll need for this course. Hopefully it should be, easy for most people. We're going to try and have some online resources as well. But, just be mindful of that. That is the part of software engineering that does kind of suck. Errors, dealing with installation. But once you get through it once, we will, you should be good for the rest of the semester. We'll have all the TA's office hours upload soon. Mine right now are Tuesdays from 5 to 7 p.m. So I know that there is a 5 to 6 p.m. section on Tuesday. I'll be available after that as well. But we'll have all those available on Piazza and B courses. There will be 2 midterms for this course. If you have a time conflict with either of these, we will send out a survey soon. But please make sure that you're writing these on your schedule. They will both be 7 to 9 p.m. The midterm on 11/5 right now, they did not confirm the room yet, so it may change. That is a Tuesday, but it will be Tuesday, Wednesday, or Thursday of that week. And as soon as we have a confirmation on the room, we'll get that out to you as well. And just a reminder, if you need accommodations for DSP, please just let us know, and we'll work with you to make sure you have everything you need there. So, micro quizzes. There's already been a question about this. I'm not sure yet whether we'll announce micro quizzes in advance. But the idea here is that frequent quizzing really does help you learn the material better. These micro quizzes are going to be simple. They're going to be, one question usually that is about 5 minutes. We'll send you a link to probably B courses, maybe Gradescope, something you're already using. But what this chart shows, this is one of the better studies on quizzing. is the retention of people who had frequent quizzing and how long after they remember the material. So you can see that cramming works pretty well if you're going to only try and retain something for 5 minutes. And with quizzing, it has the complete inverted effect with after a week of quizzing, or 1 week after, when you have more frequent quizzing, you are much more likely to remember the material. And so the amounts of time that people spent studying are cramming, and a little bit of quizzing, and then mostly quizzing and no cramming, which is basically, if you are keeping up doing the readings, if you decide to do them right before lecture, I applaud you for getting up early and doing something before a morning lecture. But that is sort of the point, is to help you just encourage you to keep up with the material. But if you end up having missing a micro quiz or two, it is not a big deal. They will not be anything that are designed to hurt your grade. They can only help your grade. If you are just randomly getting all of them wrong, that's not going to help you. If you're struggling on homeworks and exams, and we're doing grading, and it's like, well, you haven't answered any micro quizzes, that will be a concern. But if you're keeping up with the course, then micro quizzes can only help your grade there. We're still kind of messing with the exact details of grading, but the idea here really is that for all these bits and pieces, you don't need to focus on the points. If you're keeping up with the work, you will be able to succeed in the course. So, take them seriously, but don't stress about them. There are very few instances of micro quizzes sort of becoming a blocker for anyone taking 169. They are meant to just keep you sort of, give you checkpoints along the way to make sure that you're doing, you have some feedback and you're doing well. So the other bits and pieces of sort of course policies. So a couple past runs of CS169 have had sort of a lunch where I'll probably do this Tuesdays around lunchtime, 12:30 to 1 or so, Northside or Soda. But if you are reading about software engineering, have questions, want to talk about that, excuse me, not necessarily just class, questions, but the wider world of software engineering, you are welcome to come. Just bring a lunch. If you've read a good blog post, if you want to hear other people's interesting blog posts that they've read, that'll be a great place. Reference letters. So past versions of 169 have also done this, is if you are keeping up with the course, if you're making a good faith effort, you are doing reasonably well in the course. This does not mean A+, but you are keeping up, you're studying, you're practicing for exams, then I will write you a reference letter if you give me enough notice. You cannot tell me the day before that you need a reference letter, because that will not happen. But the point being here that we will see your work on projects. We'll see how you work in more than just an academic setting in this course. And if you need that for grad school, for an employer, that is something that we want to be available and provide you with as well. And so the other thing that we want to do to keep you engaged in the course is allow you to submit exam questions that you think could be good candidates for the exam. So when it comes closer time to getting the midterm set up, we'll post more about this. But the idea is that if you are paying attention, what are the types of things that you think would be very interesting problems to solve on the exam? So these are not memorization questions. These are not, the nitpicky details of, Rails and the active record framework. Like, these are things that if you were presented a problem on an exam, a scenario, a situation you would find interesting, you could submit that to us. And then assuming, we get enough, we will review them and make sure that they're appropriate level of difficulty. We will tweak them as we need to make them appropriate, for everyone to answer. But then we will provide the other questions available to students as well for studying material. So, you'll have plenty of examples that look like the midterms to study from. You'll also have past midterms available we'll provide those out as well. So there'll be plenty of opportunities, but the idea here is to keep you engaged in the course as well. So that is the end of the logistics section. We are also about, most of the way through. So questions on logistics, the course, things like that. Yeah.
So I'm guessing there's no final?
There will be, yeah, correct. There will be no final for this course. Yeah, there will be no final. Your projects, are what are really in place of the final for this course. That is your body of work. That is where you should focus your time and effort, into the projects that you're working on as a customer. When it comes time to the final, we will do. It will not be an exam, but there'll be some project presentation tasks, which are to be determined right now. But in the past, we've done sort of review videos. Previous iterations have included a poster session. I don't think we're going to do that this semester, but there'll be something like that, which will give you notice on anything that needs to be scheduled. But no final exam. Yeah, in the back middle.
Oh, so it's all right if we have the first edition of the textbook?
Yeah, the first edition of the textbook is the only one that's released right now. There will be a couple chapters. The two that are coming up first are noted on the syllabus, where there are drafts of the second edition, but there's a link to the PDF. So anyone can just download that draft chapter. Yeah, other questions? Oh, yeah, on the side? We will send out the sign-up form this weekend or early next week. Go to any section on Tuesday. If you have an idea of what time is going to work best for you, if you have an idea of your project groups, try to go to those sections first, since that will kind of give us an idea of how things will balance out. But we'll get you into sort of finalized sections for the week after next. Other questions? Yeah, in the middle, I think. Yeah. Was someone raising their hand over there?
Oh, yeah, sorry.
Yeah, go ahead.
Where are the sections actually?
Yeah, they are in classes.berkeley. They are all, I believe, now in 405 SOTA. So Tuesday 1 to 2, 2 to 3, and 5 to 6, I believe. They're on classes.berkeley. They'll also be on the B Courses homepage tonight if they're not already. But yeah, they're all in 405 SOTA. Other questions? Yeah.
Is there a list of which TAs are teaching this?
Yes, that'll be on B Courses. It's not right now, but it'll be on B Courses. Yeah. Other questions? Yeah, in the front.
And how would the final presentation look like? Is it towards customers or towards the class?
Final presentations will be more towards the class. So in the past, we've done short videos that you record as a team, which are demo walkthrough. And some semesters, students have wanted to sort of vote on best presentation or most interesting project. I don't know if we'll do that this semester, but it'll be more geared towards the course with what we do. But we'll have more details on that later in the semester. Don't stress about it now. The end of the semester is practically, infinite time away as far as everyone's concerned. Other questions? Just wave your hand if I'm missing anyone, or just shout it out. Yeah.
You say the book is online for free?
The book right now is not free. It is available online though as an ebook. If you have a problem paying for the book, please let us know and we can work that out. But it is available on Amazon. There's also a paper edition if you would like a paper version. And then certain chapters of the second edition will be linked just on the syllabus in a draft state. Anything else? Questions, logistics? I'm missing anyone? No. Okay, cool. And if I do ever miss someone as a question and I can't see you raising your hand, just feel free to shout out and stop me. We'll have a fun thing hopefully next week regarding questions. But we can talk about that then. So for the last 20 minutes or so, this is an introduction to software engineering as a discipline, the changes, the history, and so on. So this is a brief sketch of the transition from what is called plan and document to Agile as we know it today. So assuming these videos work, these are a couple, let's see, of software engineering's greatest hits. Yeah, no. Yeah, come on, computer. No. Okay. We are going to try this again. Oh, that's okay. Okay.
Décollage.
So that was a software bug, and let's see if the other one works as well. No, no. Okay. Why is the internet not cooperating? Okay, well, the internet is not cooperating with me today, but the other of software's greatest hits is a test of an airline autopilot, which was being flown entirely on autopilot, and it ends pretty much the same way as the first video. So there is a whole list of history's worst software bugs, but the point being here that software engineering as a discipline matters because in certain situations the stakes are extremely high. Fortunately for you, fortunately for the projects that you'll probably be doing in industry, these stakes are not so high, and there is a lot of solace in the fact that if I were to put a bug in Gradescope, which has occasionally happened, no one is going to die by that bug. If it takes a few more minutes for someone to get their grades, that is unfortunate, but it is not a huge disaster. So there are cases where the stakes matter. There are a whole list though of interesting things in this Wired article. So if you enjoy reading about explosions, disasters, things like that, I encourage you to take a look at the article. So 1968, the late 60s are when the idea of software engineering as a discipline starts to exist. And one of the ideas that starts to happen.
Aircraft manufacturers have tried to fix that problem by designing the pilot out of the cockpit. This is the first fully automated plane, flown by a computer.
You can hear at the very end, oh no. Well, so aside from the fact that the, internet led to a spoiler, I don't know why that happened, but that's okay. The point being here that, again, software matters. And so, there's a lot of things that are, unique to software. So, we compare, the early days of building software, compare it to a lot of infrastructure projects. How do we, build public infrastructure? Well, we go out, we plan, we gather all the requirements, we estimate costs, we hire people to document, we generate timelines, and then we start building, and we end up with a bridge, a public transit system that, hopefully meets all the requirements that we've set out. So this process is roughly called plan and document, which is before we do anything, let's plan everything out as detailed as possible. Let's create a timeline for which we can measure progress. Let's make sure that we understand everything. And then if anything changes, let's go back and make sure that's documented, that's clear. We update everyone on the process, and then you, in some cases, maybe have to start over building something or revise that. And, it can certainly work out. So this is also known as by the name waterfall, which you've probably heard of. If there are, sort of two dogs in the fight, then it's waterfall and agile. But in a lot of ways, there are elements of each that we'll see are similar. But the basics here are pretty consistent. So start with, for waterfall, start with requirements, write your design, implementation and integration. So, write everything, design it, build it, test it, and then put it out there and maintain it. And so, the idea here is that each of these steps is finished before you, begin the next one. And so that, ostensibly makes a lot of sense, right? Like, why are we going to build something if we don't know what we're building? But as we'll find out, that there's a lot of potential reasons that. So this is a really great example of where waterfall types of methodologies succeed. So the Space Shuttle program is about 420,000 lines of code, and in the sort of past 3 major versions. So there hasn't been any development in the past 5 or 6 years, 8 years now, I believe, since it's been retired. But the past 3 versions, there's less than 1 bug in each version, which is pretty amazing for a project that has almost 500,000 lines of code. In almost any startup type environment, that rate just doesn't happen. The circumstances are obviously different there, but that is that is to point out that these methodologies can be successful. They are appropriate in many cases, and when we're looking at the success, so the Software Engineering Institute at CMU rated it as the highest maturity for a software project, which again, like measuring kind of quality by one measure, and then adding GPS to the shuttle program. This was obviously now more than a decade ago, but 6,000 lines of code generated 2,500 pages of documentation. So changing 2% of the code base leads to 2,500 pages of documents to be able to write that change. And so that is an investment that leads to a very different processing needs. But what, if we could classify something as different about the Space Shuttle program, what is something that's different about this process or the needs of the shuttle software than some of the apps that you'll be building today or you might work on in the future? Like, what's one piece that would be different about them? Anyone? Anyone want to take a guess at what might be different? So, oh, is there a hand? Sure. Oh, yeah, go ahead. Sorry, lights.
Yeah, I was going to say constant feedback and
Yeah, so in terms of our software has constant feedback, or the shuttle program needs it, or? Yeah, so I think feedback is an important piece. Is there anything else that would be a good reason why this might be different as well? Yeah.
It's really expensive.
Yeah, definitely cost. And I think those two combined kind of sum it up. And a corollary to the feedback piece as well is that once the shuttle software is built, it's very stable, right? There is a known entity of the shuttle program. There's only 6. There were only ever 6 space shuttles that were built, and that were running. Not all of them were, all running the same version all the time, but that was a sort of known entity. And so today's software, the projects that we're working on, the costs are not as high, the feedback cycles are much quicker, and that software will adapt and live on much more than something, than something like a space shuttle program would. So this is a great quote that you will all learn to have experience with. It's just what we asked for, but not what we wanted. And if you've taken a design course, CS160, or if you work through like Berkeley Innovation as a club, anything like that where you have gone and worked with a customer, if you've done any consulting, you will become very familiar with this phrase. Users do not always know what they want. Sometimes, that's just getting something wrong. But in other times, that's just changing requirements. So, and this is, if you take something away here, another one of the big things, software is adaptable, right? We can deploy code hundreds of times a day if we need to, right? Like Facebook, Google, GitHub, all these tools that you use are rapidly evolving, responding to changes, fixing bugs, adding new features on demand. We don't have that ability with a space shuttle, right? Once it goes into space, however long, there's not going to be any time there or necessarily the resources to address something. If you build a bridge, then, you can't just go ahead and add a lane to that bridge, right? It's built. It has been done. I forget when exactly it was finished, but the San Mateo Bridge in the South Bay, they added an additional lane because Bay Area traffic is bad. So it makes sense, something logical to do. Adding one lane of traffic cost more than the entirety to build the bridge in the first place because once something physical is out there, adapting it and maintaining it is hard. Software is amazing in that we have that advantage that we can just adapt it and build it. So just a few examples of software projects. The green bits here are from 3 various studies of projects that were completed on time. You will see that they're all in the very low teens or even as low as 10% of projects that were completed on time and on budget. And the projects that were delivered over budget were at a rate of 3 times more costly and 3 times longer than expected in some cases. So, there is a need to adapt the way that software gets built. Even, Agile will not solve all these problems, of course, but it will help make it a little bit easier, a little bit better to adapt to that process. And so, just a reminder of, what sort of the costs are out there in the real world. So this is former Israeli Prime Minister, which I think is a great quote. Next slide is the Israeli Prime Minister. So this is again Fred Brooks, which is plan to throw an implementation away. The idea here is you probably don't want to throw everything away, but while you're building code, expect it to adapt, expect to be able to rewrite someone else's code, anything like that. And then, all right, so where are we on time? We have a few minutes left. So the The spiral life cycle is another one. This is more of an illustration. Again, don't worry about the specifics of the names with all of these, but this is sort of a bridge in the 80s between Agile and Waterfall. And the idea is, you build a prototype and you do sort of things in smaller steps. So you work with a customer, you gather requirements, you test, you build, you start it again. At each time, the steps get bigger. So your initial prototype is small, your second round of prototypes get bigger. But the challenge here is that the timeline still between interacting with a customer can be a little bit long and a little bit, sort of unstructured in that you don't necessarily get as much feedback as you want. So, the goal with Agile here is to speed this process up. So we have about, 5 minutes left. And any questions on sort of other methodologies so far? Yeah.
What's the difference between software engineers and software developers?
So in terms of professional titles, that really depends on the company. So the question is, what's the difference between software developers, software engineers? Those are generally just what companies title their positions. In a production sort of environment, what you're building is largely sort of around your team culture. I would say that most companies, most startups are somewhere between very diligently practicing software engineering best practices, and others are sort of in the space of just if it's a startup with 5 or 6 people, whatever you say goes. And so titles don't always have a bearing on that, but I would say most of them, we will be in an environment where you're trying to follow these practices. So this is sort of an introduction to all the pieces that predate Agile. I'm going to end it here today. An hour and a half lecture is a little bit long. There's sort of a lot of logistics at the beginning, but what will be important is sort of just making sure you get a feel for how things adapt and change over time. In terms of announcements, we will have some emails, and some Piazza posts this weekend. If you're not on Piazza, you'll be able to find it at CS169. If you just added the course recently, that may be why you're not on there, but you can self-enroll. Make sure you have access to the B Courses site. It should be up and published. If you can't access that, but you can find Piazza, please post there. Otherwise, make sure that you do come to lecture and section next week. And for next week, we will start with iClicker questions. Hopefully it cooperates more next week. But yeah, thank you. And then I'll be outside for a few minutes as well. Yeah. Yeah.
So for the Gradescope, you do provide us the entry code.